Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to wrap up Chapter 1 with learning about exponents, order of operations, and properties of real numbers. Okay, very important stuff, guys. Please focus. Please ask questions. Please don't leave this class today without really understanding this. The first thing I want to talk to you guys about are exponents or powers. This is something that a lot of people have problems with, and I don't understand why, but hopefully today I'm going to eliminate all those problems. First of all, this little 3 here, okay, the red, is called the exponent, or sometimes they'll call it the power. The exponent or power, okay? And what the exponent tells the reader to do is the following. It says, hey, reader, multiply the base times itself this many times. What is the base, though, you may ask? Well, the base is right here, y'all. The 2 there is the base. This is the base. That's the exponent. And the exponent tells the reader once again, hey, reader, multiply the base times itself this many times. So in this particular case, I have 3 to the 3rd power. What is that telling us as readers? What is that telling us to do? Thank you, my brothers. Multiply 2 times 2 times 2. You're going to multiply 2 times itself 3 times. And then 2 times 2 is 4 times 2 is 8. Beautiful. That's exponents. That's how you write them. Now, we're going to have a whole lot more work with exponents, I promise you, as the year goes on. But today we're just introducing you to it, okay? But I'm going to give you a lot of good info. Now, reading exponents. When you're reading exponents, guys, you always read it as follows. It's the base value, whatever that is, to the blank power, whatever that is. So, for example, I have here 3 as a base and 4 as an exponent. So this will be read as 3 to the 4th power. Okay? You're always going to name it like that. If it's the 7th, the exponent is 7, it'd be the 7th power. If the exponent is 9, it'd be the 9th power. If the exponent is 22, it'd be the 22nd power. But there are 2 exceptions. When I have a power of 2, do you guys remember what that's called? It's called, that's right, my brother, squared. Excellent job, brother. And what about when I have a power of 3? That would be cubed. Excellent, my brother. So 4 as a base with an exponent of 2 could be read as 4 squared. You guys are on fire. And 8 with an exponent of 3 could be read as, I love it. I love it. Beautiful. Not bad, right? And then, guys, just for giggles, what would this, how would you read this, please? 8 to the 7th power. Very good. Easy peasy, right? All right. Now, let's talk. Let's simplify each of these. 10 to the 7th. Mr. Moore, you really expect us to multiply 10 times itself 7 times? Absolutely not. There's a little trick here. Who knows that trick? Yes, sir. That's exactly right. What's happening here, guys, when you have powers of 10, this is the easiest way to do it. You're going to go ahead and write down the 1. Now, powers of 20, now powers of 80, it doesn't work for that. Powers of 10. Put the 1, and then according to the exponent, that's how many zeros you put. So you're going to put 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, comma, 1, 2, 3, comma. If you don't believe me, think about it like this. What's 10 squared? 100, right? So isn't that a 1 with 2 zeros? Because of that? That's going to save you a lot of time in the future, guys, okay? Now, B, 3 to the 4th power. So this is telling me, hey, reader, multiply 3 times 3 times 3 times 3. You want to multiply 3 times itself 4 times. 3 times 3 is 9 times 3 is 27 times 3 is 81. Excellent. Now you're trying. Thank you. We all make mistakes. 1/2 to the third power. Whoa, I got a fraction. Does that matter? No. What's my base now? Okay, good thing. Don't do 0.5. What's more difficult? Multiplying 0.5 times 0.5 times 0.5 or 1/2 times 1/2 times 1/2? In my opinion, I think it's 0.5. You're absolutely awesome though, man. 1/2 is 0.5. But for me, I'm going to make my life easy. So I'm going to go 1/2 times 1/2 times 1/2, which equals 1/8. Bless you. Does that make sense? Okay. Decimals. Does it work the same with decimals? Oh yeah, for sure. 100%. The base here is 0.2 and this is 0.2 squared. So I want 0.2 times 0.2, which is going to be 0.04. Remember, there's 2 decimals. So you got to move the decimals 2 places to the left. Come again, my brother? This is power of 2. No worries. Thank you, my brother. For E, 2/3 cube. Yes, sir. Okay, it's not going to be 0.4 because 0.2 times 0.2 is 4, but I have 1, 2 decimals, 1, 2 to the left. Thank you. Thank you for your honesty. It takes guts to ask. Thank you. Good job. Okay, so 2/3 cubed, this is 2/3 times 2/3 times 2/3. So 2 times 2 times 2 is 8. 3 times 3 times 3 is, yes, sir, you got a question, my brother. Oh, sorry, my man. Thank you. Now, let's talk about negatives, guys. Please pay attention to me here. Please, please, please. I've got -3 squared. When we're dealing with exponents, we must realize that the power only affects the number directly to the left of it. Directly to the left of it. So this power of 2 is simply affecting the 3, not that negative. Because what does that negative really remember? Does anyone remember? Yes! So this is a -1 times 3 squared, my brothers, which is -1 times 3 times 3, which is -1 times 9, which is -9. I went way further than you have to. You probably could have gotten it quicker. But the key here, that negative was not affected. You feel me? Okay. How about for letter G? I got -3 cubed. So this is a -1 times a 3 times 3 times 3. 3 cubed is 27 times -1, so that's -27, sir. -3 in parentheses to the 4th power. Just like the exponent okay, only affects the number to the left, the exponent also affects everything inside. So in this case, again, it'd be a -1 times 3 times 3 times 3 times 3, because it's 3 to the 4th, which is going to be -81. Now I'm going to throw you for a loop. Are you ready? Okay. Now I'm going to throw you for a loop, guys. This example states -1 basically times parentheses a -3 to the 4th power. So this is going to affect everything inside of here. Yes, sir. Oh, wait. Let me teach it. So this is -1 times -3 times -3 times -3 times -3. -3 to the 4th power is +81 times a -1, -81. Sir, my brother, thank you. Because, no, in this particular case, it's not a -1 times a 3, it's a -3 already because it's inside the parentheses. Correct. Yes, sir, my brother. That's right. That's right, my brothers. What my boy said here was, let's just do an example like that. Let's say I have a negative times a -3 raised to the 3rd power. This would be -1 times a -3 times a -3 times a -3. Negative 3 times negative 3 is 9 times negative 3 is negative 27. Times this negative 1, it'd be positive 27. The negatives destroy people with exponents because they never learned this for real. They see a negative and they just start throwing negatives all over. Great job, by the way. Thank you. Good follow-up. Does that make sense, brothers? So, last thing. I don't want to bore you. Negative 5 squared would be what? Negative 25, because it's a negative 1 times 5 squared, which is 25, which is negative 25. Negative 5 in parentheses squared would equal positive 25, because it's negative 5 times negative 5. Do you see the difference, my brothers? Thank you, gentlemen. Order of operations. If you don't know exponents, you can't use order of operations. Yes, sir. Because I don't know how to multiply. My bad. I was testing you guys. You win. No, I'm kidding. Thank you for that catch. Yes, sir, my brother. Come again? What do you mean the negative? I don't understand the question, Papa. The negative 5 bigger. I don't get it. And this guy. Yeah? Yeah, negative 5 times negative 5 is positive 25. Yeah, you're not doing 2 times negative 5. No worries. Thank you for caring. Sir. Okay. Remember, this is a good question. Thank you, my man. Okay, the question here was, why did you get a negative 81 for that if you have a negative and a negative? You cannot multiply those two first. That's where we're going with the order of operations. You have to do exponents. So this is a negative 1 times negative 3 to the 4th power. So it's a negative 3 times a negative 3 times a negative 3 times a negative 3, which is a negative 1 times negative 3 times negative 3 is 9, times negative 3 is negative 27, times negative 3 is positive 81. 81 times that negative 1 is negative 81, sir. Okay? Thank you, my man. Order of operations. Please excuse my dear Aunt Sally, okay? Number 1, please. This is parentheses. Go ahead and perform any operations inside grouping symbols such as parentheses, brackets, braces, or absolute value. You're going to perform what's in there first. Number 2, excuse exponents. Go ahead and simplify powers or simplify any exponents that are there. My dear, very important here. Multiply and divide in order from left to right. If you see a division problem first, you do that first. If you see the multiplication first, you do that first. You go in order from left to right. Last but not least, Aunt Sally, add and subtract. Oh, that was the multiply and divide. And now add and subtract in order from left to right. Read it like you're reading a book. Please, my brothers, read it like you're reading a book. Please. Okay? So please excuse my dear Aunt Sally. Parentheses, exponents, multiply and divide in order from left to right. Add and subtract in order from left to right. Okay? All right. Now, simplify. I know, guys, maybe some of you didn't write it, but that's okay. That's why I have a video. It's all good. Okay. 6 minus 2 squared divided by 2. Okay. Do I have parentheses? Yes. So what would that be? Oh, this is not negative 4. Wrong. And this is not 6 times 4 either, whoever said that. This is 4. It's not 6 minus 4 either. Guys, how about let's just stop talking for a second and let Mr. Morrow teach. Order of operations. Parentheses. 6 minus 2 is 4. Squared. Divided by 2, my brothers. Exponents. What's 4 squared? 16. Divided by 2 is 8, my brothers. I want to thank you for your excitement, but remember, just saying random numbers doesn't make it correct. We got to follow those order of operations, my brothers. Thank you so much. Number 2, do I have parentheses? Okay, yes and no. This parentheses means multiply, but there's no operation inside of there, right? So let me rephrase the question correctly. Are there any operations inside of the parentheses? No. Do I have any exponents? So let's knock that out. So I've got 5 times 7 minus 4 squared is 16 divided by 2. My dear, multiply and divide in order from left to right. So this is the first multiplication I see. So 35 minus 16 divided by 2 is 8. Now you subtract 27. For number 3, whenever you have an expression with a numerator and a denominator, yes, sir, it would be division, but you first have to simplify the numerator. And then if there was something in the bottom, you have to simplify the denominator first, my brother. Thank you. So 2 to the 4th power is the exponent here. 2, 4, 8, 16 minus 1 over 5. That's 15. Now that I'm simplified on both the numerator and denominator, you're absolutely right, my brother. Now I can divide, and that would be 3 gentlemen. And I got 5 minus 2 cubed divided by 3. Do I have any operations within the parentheses? Good. So what's that? 3 cubed divided by 3. 3 cubed is 27. Nice. And then 27 divided by 3 is 9. Nice. Good job, guys. Well done. They're going to get crazier, of course, but you just follow the order of operations, my brothers. Does that make sense, gentlemen? All right, last but not least. All right. Properties of real numbers. This is where everyone goes, I don't need this. This is silly, Mr. Morrow. Trust me, you're going to need this for word problems. You're going to need this for equations. You're going to need this for my quizzes and my tests. You're going to need this for the SAT. You're going to need this for ACT. You're going to need this just to be an overall good mathematician. Let's learn them today and just knock it out. Commutative property of addition states, no, it does not state, little dot. Sorry about that. It states A plus B equals B plus A. Mr. Moore, that's fantastic. But what does that mean in English, sir? It means that I can change the order of any addition problem and get the same answer. For example, 3 plus 4 equals 7. Well, guess what? 4 plus 3 also equals 7. That's an example of the commutative property of addition. It's the same exact thing for multiplication. A times B equals B times A. What that says is I can switch the order of a multiplication problem without changing the answer. For example, 3 times 4 is 12. 4 times 3 is 12. That's the commutative property. I can change the order of addition and multiplication without changing the answer. Little side note. Do you guys think this will work with subtraction, my brother? Why do you think it won't work with subtraction? Give me an example. Please, if you can think of one. What do you think?
I don't think it will work.
Okay, but why? Give me an example. For example, what's 5 minus 8? Negative 3, right? And then what's 8 minus 5? No, 8 minus 5 is 3. So can that work with subtraction? Yeah, 8 minus 5 is 3. 5 minus 8 is negative 3. That doesn't work. That's why you're not going to see any properties here with subtraction like that. You can't change the order. How about division? 1/2 is 0.5, but what's 2 over 1? So can you change that? Okay, no. Associative. Associative. Please pay attention. I don't know why it does that. Please pay attention, guys, to associative, okay? I got A plus parentheses B plus C equals A plus B plus parentheses C. What's going on here, Mr. Moore? This is kind of the same as commutative, right? It is, except, here's the key, guys. Do you notice how the A was on the outside here and now it's on the inside? Do you notice how the C was on the inside and now it's on the outside? That's associative. Whenever you take something out of the parentheses and replace it, that's associative. Moral, but how is that not commutative? If I have 5 plus parentheses 3 plus 2, and that equals 5 plus parentheses 2 plus 3, did I take anything out of the parentheses? All I did was change the order here, right? Even though there's parentheses here, that's commutative. Oh, okay, well then what's associative? I've got to take something out of the parentheses. So I got 3 plus 4 plus 5 here, but that equals 3 plus 5, as you can see in the parentheses, plus 4. What ended up happening here is I had the 3 on the outside, I brought it inside. I had the 4 on the inside, I brought it outside. That's the associative property of both addition and multiplication. A times B times C, in parentheses, equals now A times B, in parentheses, times C. So the A was taken out and put into the parentheses, and in this case, the C was taken out of the parentheses and pulled outside. In the example, I got 3 times 4 times 5 equals 3 times 5 times 4. 3 was outside, I brought it inside. 4 was inside, I brought it outside. That's associative. Distributive property. Distributive property states A times B plus C equals A times B plus A times C. What are they saying? When you have a distributive property, you're going to multiply the outside number to everything on the inside. So this A gets multiplied to the B and to the C. What if the F is on the other side or the variable's on the other side? Then you still do the same way. F times D plus F times E. Distributive property is like distributing a paper to everyone in the class. You give it to every single student, every single person. Yes, sir, my brother. Okay, for the exponents, there's a little bit of different rules there. We'll get to that eventually, sir. But there is a way to distribute the exponent, but it's when you raise a power to a power. Yes, sir.
Like for that example, could you just, instead of step 3 plus step 4, just make that 7?
Make that 7 and multiply by 2. Oh, yes, of course. If you wanted to solve this, you could use order of operations and do 7 times 2. But that's not the skill. The skill I'm teaching is distributive property. Guys, I'm going to go ahead and finish. I know you got to go eat lunch. Thank you. God bless you. Have a great day. I hope you learned a lot. Follow your calendars, please. Try to leave relatively quietly because I got to finish recording. Thank you, y'all. So the identity property. Think of identity like looking at yourself in the mirror. So what do you add to yourself? What do you add to anything to find that same number? Well, it would be 0. A plus 0 is A. Okay? So what the identity property states is that anything plus 0 is itself. For example, 5 plus 0 equals 5. What's the identity property of multiplication? Well, again, we got that key word again, identity. Think of looking at yourself in the mirror. So what number would I multiply to any number to get itself? Hopefully you're thinking of 1, because A times 1 equals A. For example, 5 times 1 equals 5. Okay, that's the identity property. Additive inverse. We learned additive inverse already. I just wanted to refresh your brains. Additive inverse states that A plus negative A equals 0. So what that says in English is if you add a number and its opposite, it will always be 0. So for example, 8 plus a negative 8 equals 0. That's the additive inverse property. The multiplicative inverse property states that 1 times A times 1 over A equals 1. So what that's saying is that whenever I multiply a number times its reciprocal, it equals 1. For example, 3 times 1/3 equals 1. Because when I multiply a number times its reciprocal, it equals 1. Zero property. And actually, this should be really, my bad, this should be called the zero product property. Okay? Sorry about that. And the zero product property states that A times 0 equals 0. It states that anything times 0 is 0. So 6 times 0 equals 0. And then closure property of both addition and multiplication is pretty simple. Closure property states that when I have a real number plus another real number, my answer is going to be a real number. 3 plus 5 is 8. They're both real numbers. That's why the sum is a real number. Closure property of multiplication. When I multiply a real number times another real number, I'm going to get a real number answer. So for example, 4 times 2 equals 8. 4 is a real number, 2 is a real number. The product is 8, which is a real number. Thanks again, y'all. Hope you learned a lot, and have a wonderful day. Bye-bye now.